Hello students, this video intends to help aid in your understanding of the addition rule and mutual exclusivity as they are presented in the Stat 1040 and 1045 classes. Within this video, we will touch on objectives 4.1, 4.2, and 4.4 of Unit 4. We will be covering the concepts shown on screen. After some explanation, you will have a chance to practice these concepts at the end of the video. Let's get started. We will begin by defining what it means for events to be mutually exclusive. In probability, two events are mutually exclusive if they cannot occur simultaneously. The occurrence of one event excludes the possibility of the occurrence of the other event. To help with our understanding, let's look at an example together. Consider a deck of cards containing 52 total cards. If we draw one card out and want to draw an ace or a jack, these outcomes are mutually exclusive. An ace card cannot also be a jack card. Conversely, if we wanted to know the chance of drawing an ace or a heart, these events are not mutually exclusive. A card exists that is both of these things, that being the ace of hearts. Now let's continue our understanding of probability by exploring the addition rule. The reason we explored mutual exclusivity first is because in order to perform the addition rule, the events we are looking at must be mutually exclusive. If we check and they are mutually exclusive, we can proceed with the problem. In our addition rule, the probability of event A or event B is equal to the probability of event A plus the probability of event B. Our key words to look for in a problem that indicate we will be adding probabilities together are or as well as either. Before we move on to an example, what do we do if the events in a problem are not mutually exclusive? In this specific class, if events are not mutually exclusive, the correct answer is that you cannot proceed with solving the problem. Let's look at this example together to improve our understanding of the addition rule. What is the chance that when flipping a coin, we will flip either a head or a tail? Note the use of the words either and or within the problem. These words let us know that we should use the addition rule. However, first we must check if these events are mutually exclusive. If we flip a coin only once, can it be a head and also a tail at the same time? No, these events are mutually exclusive. So now we may use the addition rule to solve. The probability of head or tail is equal to the probability of head plus the probability of tail. Knowing the chance of flipping a head is 1/2 and also 1/2 for flipping a tail, we can easily solve the following. Probability of head or tail is equal to 1/2 plus 1/2. When we add these probabilities together, we get an answer of 1. Now that we have reviewed some of the concepts of probability, let's do some practice to check our understanding. Problem number 1. We are tossing 3 coins, noting whether it lands on heads or tails. Which of the following scenarios describes outcomes which are not mutually exclusive? A. Flipping all heads or flipping all tails. B. Flipping all heads or flipping at least one head. C. Flipping a head on the first toss or flipping a tail on the first toss. And D. Flipping no heads or flipping all heads. Pause to answer, then press play to check your work. The correct answer is B. Flipping all heads or flipping at least one head. Remember, events are only mutually exclusive if the occurrence of one outcome excludes the possibility of the occurrence of the other outcome. In B, we could flip all heads and flip at least one head, since that one head can be contained within 3 flips of all heads. A is mutually exclusive, since if we flip all heads, we could not also flip all tails. C is mutually exclusive, since if our first toss is a head, it cannot also be a tail at the same time. And D is mutually exclusive, since if we flip no heads, we cannot also flip all heads. Problem number 2. We are picking out blocks from a toy chest. Within this chest, there are 5 blue blocks, 3 yellow, and 2 green. Question: what is the probability that the first block we take out of the chest is a blue block or a green block? Pause to answer, then press play to check your work. Answer: here are some ways we can represent our answer. To get to this conclusion, we must identify that the problem contains the keyword or, letting us know that we must check if the events are mutually exclusive, and then utilize our addition rule to solve. If we are only picking one block out and that block can only be one color, it cannot be blue and green at the same time. Thus, our events are mutually exclusive, and we may proceed. Let's further break down the problem-solving process. Begin by writing out exactly what the problem is asking us for, using our addition rule equation. The probability of blue block or green block is equal to the probability of a blue block plus the probability of a green block. Now we can look to our problem to fill in what those probabilities actually are. The probability of a blue block or a green block is equal to 5 out of 10 plus 2 out of 10. There are 10 blocks total, which is why that number is our denominator. The chance of blue blocks is represented by the 5 possible blue blocks we can pick over the total 10 in the box. Likewise, the chance of green blocks is 2 possible green over the total 10. Following our addition rule, all we have to do now is carefully add these probabilities together. 5 over 10 plus 2 over 10 equals 7 over 10, providing us with our answer for this problem. If these or any other concepts require some more of your attention, feel free to watch this video again, reach out to your professor or recitation leader, or utilize the free tutoring services offered at the Aggie Math Learning Center. We hope this video was helpful, and remember that help is here if you need it.